second, I'm just going to tell you a bit about the second assignment. I know most of you have got a handle on it and what you're doing, but basically you're pretty good at using multisim now, right? So you can design your own printed circuit boards and all the rest of that kind of stuff. So this one is open loop. You're free to choose any circuit you want, but there's a risk associated with that, because if you choose something that's too complicated, you'll never finish it or get it to simulate or even get it built. And if you choose something too simple, I'm not going to be very impressed when I compare it against someone who's got something with greater complexity. So there's a fine balance to be had there, and you should think very carefully about that before you make your circuit choice. That's why we're here, because, well, you show us the circuit that you think is a good idea and we'll tell you whether it is or not. For example, in the past, people have said, I want to make this, and it's a 16-bit A to D that you've got to import from Japan and it costs 35 quid a go or whatever. That's a non-starter, because you won't get the parts in time, and you certainly probably wouldn't get authorization for that amount of cost either. So try and keep what you're doing modest. Now, some of the ones we've got suggested on here, a simple radio receiver or transmitter using transistors and discrete components, that's okay, but they're a job to get to simulate in multisim. And certainly a radio receiver, all you can really do is inject a sine wave into it, and that's not really the same as having a radio receiver, but you can test the various stages in isolation if you want. A digital capacitance meter, nobody's ever took that one yet, but you can measure capacitance by using a few little tricks, and then you can display it on a 7-segment display. Bar graph based spectrum analyzer, lots of people have made this in the past, and really all that is an extension of what you've done already. So you saw before, when the resistance got above a certain level, the light came on. Well, that's just a comparator, and what you can do is you can put lots of comparators next to each other and get them to light up LEDs according to the amount of signal strength coming in. So that's quite a good one. DC to AC inverter, so anyone who's got a caravan or a boat or something will know that you can convert 12 volts into 240 volts. Well, we don't want you doing 240, but you can certainly do 50 safely enough. So you can take a DC supply and turn it into an AC source if you want. Resonant power transfer system, someone's doing this as final year project, and I think I've got an MSc student doing it as well. You saw that little circuit that I made in here the other day with the propeller blade on it. So transferring power over the air basically, that's quite a nice little project, that one. Amplifier, we get lots and lots of amplifiers every year of different types. Probably better to build it out of discrete components. Maybe an op-amp at the start and some transistors for the power amplifier stage. A filter, now by a filter I mean something possibly that's bass, treble, and something with a bit of gain in it or something like that. We have had someone in the past try to build something akin to a mixing desk, but obviously really all you're doing is repeating the same circuit over and over again. Energy harvesting circuit, I'll let you do a bit of research on that. A digital dice, now these seem to be very popular. Digital dice are good because they combine analog and digital together, so and they work, that's the other thing, so you get a result at the end of it. A hidden wire detector, there's lots of circuits out there so that you could run it across, say, that wall over there, and you can work out where the wires were or where the studs are in the wall. That they come up pretty much the same as wires, so you can see hidden structure underneath the wall, and just do a search on wire detector circuit and you'll find something. A circuit of your choosing. Now, a lot of people take this one, and obviously it comes with a risk that we haven't built or tested some of the circuits that you're going to try and take on yourself, and so you want to be sure of the source you're getting it from. Just because it's on a Google search doesn't mean say it works, okay? More often than not, things that people put on web pages, they deliberately modify a little bit so that you can't exactly copy them. So exactly the same as before. You've got to fully simulate the circuit. You've got to have an attempt at getting it running. And I think the minimum attempt at getting it running is to put it on breadboard. Now, the printed circuit board, which comes out of the other side, we can make it for you, but you'll need to meet a deadline for us, because otherwise we can't send it off and get it back in time. Now, there's a risk that it may not come back until over the Easter holidays, but you can still have the physical realisation of your board. Now, I'll have a conversation with Mike in a minute, and we'll decide where we're going to get you to send these Gerber files so that we can send them off. The office upstairs will take a zipped file that we upload to PCB Way, and they should be delivered in a couple of 3 days. Now, the other decision to make is whether you're going to go surface mount. Well, prototyping on breadboard isn't really an option, is it? So you're going to be using through-hole technology if you're going to prototype on breadboard. But if you're designing a PCB, because you're now an expert in it, you might like to think, well, it might be a better way forward if I did do surface mount on my PCB. Populating your PCB, well, obviously if you submit an assignment and at the end you show me a PCB that we ordered from PCB Way and you soldered it up and it works, I'm going to be extremely impressed. But that's certainly in the minority. We only saw 1, possibly 2 last year that actually managed to do that. But if you want to do that, you can. But I think one of the nice outputs from this is that regardless of it, even if it is over the Easter holiday, and we're still in a position where we can get you that printed circuit board. But that comes with a cost in that you'll have to have those Gerber files to us by a set time. Okay, and we're going to set what that deadline is. Now, it's not absolutely compulsory to get it made, but if you do and you meet the deadline, you'll get more marks, because that comes down to the realisation again, doesn't it? So if you want to chase those few percent, then that's the sort of deliverable you should be looking at. And certainly at the end, if I do see a printed circuit board that's populated and tested, yeah, I'm going to be a bit more impressed than somebody who just did it on breadboard. I mean, come on, you know, that's how it works, right? Okay, so scour Google and find some circuits that you're interested in, and stick your hand up and we'll say, yes, we think that will probably work for you, or no, that we can't get those components for you. That's going to be, we can, but you'll miss the deadline and you won't be able to test it on breadboard or anything else. But the primary thing that you should be doing is, as soon as you've decided what your circuit is, get it simulated, test the various components. Remember, you can't always test a circuit in its entirety, but what you can do is you can break it into chunks that you might have a preamplifier, followed by a filter, followed by a driver stage or something. You can pull those different parts out and you can test those different parts in isolation without actually testing whether the whole thing works altogether. That's fine. That's fine. And are you rewarded for realisation? Yes, you are. I would expect to see some demonstration of something working, even if it's on breadboard. Okay, marking criteria, that's all on the web page, and the assignment itself all on the web page. You've obviously got the hang of what's going on, because I've been having a sneak preview at some of your reports and they all look pretty good to me. So that's basically what you've got to do for the second one. You've got to simulate it, PCB it, build a prototype of it, test it, write up what your findings are, and then stick that in a report the same way as you did before. Does that make sense? So I think really today is a shopping trip for those of you, some of you have started on this last week, but really it's a shopping trip to try and find out what circuits you like the look of, what components it has, can you get those components, and then really starting to think about putting it into multi-sim. Any questions? Okay, I'll discuss with Mike the PCB deadlines and then we'll stick that on the board in a minute, okay? Good, off you go.